start with today's contest then. Chef is re-recording the not target and just to buy. First WPK. Huh? W comma P comma K CN W P K so it's equal to 0. Answer plus is equal to minimum of W comma K into 2. Okay, K minus is equal to W. K is equal to max of K comma 0. Answer plus is equal to K. I see out answer and L. 10 4 15 6. Huh? 0. 10 4 15 6. Correct. Wolf town है ना अगला problem. Each in certain points has n animals living in it. Each animal is either a wolf or a bird. ठीक है. Straight line position बना x-axis. Is a bird of one is a wolf. One of the wolves like to eat the birds. Or x plus 1 the wolf at position x will eat the bird. ठीक है. X plus 1 wolf is at x, bird is at x plus 1. Wolf will eat the bird and it will move to the position x plus 1. Note that the birds never move. A wolf doesn't eat a bird. That doesn't eat a bird doesn't move, and each wolf eat at most one bird in every second. A bird is called safe. It is never gets eaten by a wolf. Are safe. So I suppose 0 is bird, right? So 3 0 0 1. I suppose ठीक है. तो input is n string n. Because if there is a wolf, is it correct? I think it's correct, because if there is a wolf, it will eat all the birds to the right of it. One is a wolf now. N is 100, T is 100, n to the power 4. Okay, so T L E. Pro. Let for an array of length n we define function of a as follows. Let s denote the sum so far, and h denotes your happiness. Initially s and h are both 0. Then for each I from 1 to n in order, if s doesn't double upon adding ai to it, add 1 to your happiness. That is, if s of ai is not equal to 2s, add 1 to h. Note that if s plus a of I is equal to 2 of s holds instead, h doesn't change, then add ai to s, correct? F is defined to be the final value of h. Okay, the function is defined to be the final value of happiness. Cool. Array. If I want to fill the as however you like, find the arrangement of array that maximize f of a. Cool. Cool. I suppose this should be the answer. Descending order. N and a of n, right? Intense. Maximizes na maximizes f of a, right? 3 2 1. If I'm arranging it in descending order, I think it should work. Or oh, नहीं, एक केस है. 663. The answer should be 636. नहीं, ये गलत हो सकता है. 663 में आंसर should be 366 rather than 663. I knew that. If n is greater than 1, swap a of 1 comma a of n minus 1. Because it is hold true, right? I think this should work. If n greater than 1, then swap this. Which means these all are same. So, correct answer, right? Cool. Okay. So I'll tell you the solutions once after the contest is done. I'll try to explain the solutions. You're given a binary string s of length n that asks to find any permutation p over to n that satisfies the following conditions. For each index I, s of I is 1, there is a contiguous subarray of p. Binary string s of length n. Find permutation p. For each index, if s of I is then there exists a contiguous subarray of p such having length I whose maximum element is I. Alright, so there should be this and a maximum is. For more formally, there must exist a pair of integer L to R such that is I and this is this. If this is 0, then for every continuous array of cube length I, its maximum element is not I. Cool. More firmly, for every pair of integers, then it must hold that p of this. More for if this for every integer is this, it must hold that max of this is not equal to I. If there are multiple possible conditions that satisfy the condition being defined, then no valid permission minus 1 instead. So let's see what is minus 1. So if first element is 1, so let's suppose this is a binary string 0 1 1 0 0 1 1 1. So this is minus 1 because there will always exist an array of length 1 that has this. So neglect this. Okay, and then for every, let's suppose 0 0 0 0 0 0. So this should be 1 always. This is also minus 1. Why so? Because yeah, in this array, so this should be 1 as well as this should be 1. And now let's see what are the values in between that can come. So, and n is 1 or 2. If n is 1, see out 1, n is 2. Cool. Scribble. So let's say this is 0 and everything is 0. So what does that mean? There should not be any subarray of length 2 that has this maximum. So let's put it here. Cool, this number. Then there should not be this, which maxes this. So let's put it. No, we can't. So if this has to be maximum, right? Let's suppose this has to be this. So 1 2 3 4 5 6 7 and so on. This will be the answer of 1 1 1 1 1 1 1. But if something is 0, let's suppose this is 0, then just push it to the back. Does that work? Does that work? I suppose yes. And how to push it? Just start from left, which is 0. Just push it to the right. Go in a vector, push all the elements that are 1, and what are zeros, push them again. So it should work. Why it should work? Because this is increasing. Yeah, so I suppose this should work, right? So for ones, I have to push it from the starting, and for zeros, I have to push it from the end. Cool. So what is this? Input is n and then s. Not vector string. Seen as अरे बताओ देवांश भाई यार शांत शांत शांत. If if s of I is 0, s of n minus 1 is this. ठीक है, if any of is 0, it's minus 1. Now if s of I equal to 1, answer dot pb I plus 1, I am n minus 1 I get equal to 0, I minus minus, if s of I equal to 0, answer dot pbi plus 1 should work for and oh नहीं see out answer of I. Let's check if n is this and 1 see out 1, this is this. If s of 0 see out answer of I. Answer of I, this should work. 1 second. Wrong answer. Skip the first test file as well. अच्छा okay Subarray max global rank 39 भाई साहब so let's visualize this, right? So let's suppose my final would be always 1, so let's suppose take my final n to be at the last, 1 to be at the no sorry n to be at the first and 1 to be at the last. Now it's 0 0 0 1, let's go 1 1 and 1, so 1 2 3 4 5 6, so 6 1. Now I want 5 to also come, so right, I can say 5 is here, because now see all the elements to the left of 5 are less than 5, so 5 will always be here, right? Now let's suppose 4 can't be here, so 4 shouldn't be here, so just keep 4 before 5, right? Cool. 3 shouldn't be here, keep 3 anywhere before 5. 2 shouldn't be here, keep 2 anywhere before this, or I would say keep it here in this bucket. Why to keep 6, 5 and 1 is there? Let's suppose everybody is 1, 1, 2, 3, 4 is not 4, 5. This is 6, this is 1. 1, 2, 3, 4, 5. 1, 5 is there. So let's take 5 is here. Let's keep 5 here. And then 4. Let's keep here. 3, 2, 1. 3, 2, 1. 3, 2, sorry, in decreasing order. So what will happen is 4, 6, 1, 5, 3, 2. But see, 3 is not working here, right? So 1 has to be here. 1 has to be at the end. 6 has to be here. 6 has to be somewhere here. 1 has to be at the end. No, answer should be this. 6, sorry, 4, 5, 4, 6, 4, 6, 1. 4, 6, 1, 2, 3, 5. So what I've done is I've pushed two elements initially. Right. Now all the zeros in, let's suppose, in decreasing order. So all the ones I'm pushing in increasing order. Let's suppose this is 1 and this is 0 and this is 1. So 1, 2, 3. I have pushed 3. And no, then it can't be done, right? I'll have to take 2 with. So if ith value is 1, so there should be a subarray from where the ith element should be the maximum, and for all the elements should be a 1 to I minus 1, right? 1 to I minus 1, rest should all be there close to this I. So 1 is 1, so let's suppose this. Now 2 is 0, so 2 can't be with this. So I can't keep 2 here. But if 3 is done, so 3 has to be here, then 2 has to be here. Okay. Now if 4 is there, so 4 can't be here. 5 is here, 5 can't be here. But if they are not there, they can be here. But if they are there, then, and if 6 is true, so 6 has to be here, and then 4 and 5 has to be there, right? So the logic is as follows: take 1, push it to the front. Now if 2 is there, push it there. If 3 is there, push it there. If 4 is there, push it there. Push all the things, like 4 is there, 5 is there, 6 is there, let's suppose all are there, so it should be this. But if nobody's, some key is missing, like 3 is missing, so swap 3 and 4. So 1, 2, 4, 3. No, so for the maximum, so 1, 2, 3, 4, 5, 6, take this. If 5 is missing, swap this. If 4 is missing, swap this. So 1, 2, let's suppose 4 and 5 both are missing. 3, 6, 4, 5. This will be the answer. 1, 2, 3. Let's suppose 3 is also missing, so 3 is here. So I think this should be the answer. If this is 0, this. Answer of I, array yaar, equal to I plus 1. if s of I is equal to 0, swap answer of I answer of I minus 1 I plus 1. Why? This is 0, so swap this. And 1 है तो this, 1 and this is 0, to see out this. Else if की जरूरत नहीं है. If this is this and this is this, if s of 0 is 0 and this is 0, see out minus 1, because both can't be this. For n I is equal to 0, I less than n. Then just start on swapping from the right hands, and I suppose this should be done. Okay. Huh. sig term किस में आया? sig term कैसे आ सकता है? हैं? What? Oh. One, 3, 2. Let's check after submitting also. I suppose this should work, because I'm just swapping this. Correct answer. Yeah, bro. Yeah, but time ले लिया. I took a lot of time in this. Alright, so my rank is also down by a lot. I'll have to make this fast. In fact, I can solve the full problem set, I suppose, today. Pathetic, bro. This one is the same concept as coup set. Coup set क्या होता है? The only difference is that here you only need to minimize the number of upsets in the tournament. Okay, you are given two integers n and w. Construct an array A of length 2 n plus 1 minus 1. All right, satisfying the following properties. A of 1 should be 1. For each I, either A of I is max of A of 2 of I and 2 of I plus 1. So it's somewhat like a tree. It's 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. So this is 2 into I, this is 2 into I plus 1, I suppose. A of I is this max or min. The number of items among this which is max is minimized. Either this is this or this. The number of indices among these for which this is max of them is minimized. Okay, it has to be minimized. The last 2n elements of A form a permutation. So the last 2n elements would be the elements at the leaf. Cool. Forms a permutation of 1, 2, 4. All right. Formulas for me, you have to set up a single elimination tournament bracket on players labeled this. So okay, so what this means is at the leaf node 1, 2, 3 till 2 to the power n, all the elements should be present at the leaf node, and you will have to make sure that this is max of any to leaf is minimized. The indexes have been minimized, and this has to be w. Okay. And w is, I think w is 2 to the anything between this. 400, 109. 1 minute rain is bad. Hmm. So I'll have to minimize such. So I'll have to make W, and I'll have to make sure that this is the minimum of this. So here somebody is W and somebody is greater than W. All right. So let's suppose W is my answer. So let's suppose everybody that is, let's suppose if W is 2 to the power n. All right. So what I'll have to do, I'll have to take 2 to the power n. This is in this leaf node. So this parent will also get 2 to the power n, and its parent will also get 2 to the power n, and so on, because then I'll have to take the max of them, and till the root I'll have to take all the maximums in this path. Apart from that, I can take anything, like I can take all mins, and I will get eventually into this node and this node I'll take the max. And so all right, so for this path, if it's 2 to the power n, for one path I'll have to take, so 1 can be then 2 4 4 and 8 16 and so on. What I can do is, in all of these values I can place 2 to the power n, and accept that, because 1, this is 2, this is 4 and so on, this is 2 to the power n plus 1 2 3 4 5. All right, so 2 to the power n 6 7 8. Cool. And this path will always consider the contain the max. Do I need to take the max always? Yes, I need to take the max always. That's when only get 2 to the power n. Let's suppose if the number is 2 to the power n minus 1. N minus 1. Let's suppose this is the number. So what I can do is, on one path I have this number. So I can always take min and 2 to the power n minus 1, n minus 1, and 2 to the power n I can place here, and eventually once again I'll take the min, right? I'll take the min, so I'll get this here, and so on. I'll proceed, then I'll have to take the max. So this is the minimum iteration. If it's 2 to the power n minus 2, so what I can do is I can take this element, I can take 2 to the power n minus 2, 2 to the power n minus 1, and then it will go the parent min, and then this parent's parent 2 to the power n minus 2. This will take 2 to the power n. Cool. And what will happen is, n should be very small, right? N is 17, so it's 2 to the power 17. All right, so this will also take min. So it's easy. Then it's easy. And if it's 1, all right. If W is 1, then I'll always take the minimum. There's no need. If W is 2, I'll always take the minimum. There is no need. So, all right. There is some issue with the internet. So how many operations I need? I need at max 17 operations, right? So let's suppose this is 2 to n 2 to the power n elements, 2 to the power 17 elements in the last level. So 0, 1, so it will be 18 levels, right? Cool. So it will be 18 levels, and for each level, so there will be 17 min or max operations that I like to minimize or minimize these max operations. So if w is less than equal to 2 to the power n minus 17, then no need. You can output any array such that to take the minimum. Is it okay? No, no, no. So if w is there, I need to make sure w wins. So I need to. So this is the output. I don't care about anything else. Just I want w to be the minimum while going up, and I don't care about anything. But if w is 1, so any array would work. W is 2, then I'll take 2 here, and I'll take 3, 4, 5, 6, and so on. If w is 3, so I'll take 3 as here. I'll take 4, 5, 6, 7, and so on. If w is 4, I'll take 4 here, 4, 5, 6, 7, 8, and so on. Because I'll have to take one max operation. If w is 5, I'll take 5, 6, 7, 8, 9, 10, and then 4, 3, 2, 1. I'll take anything. This number will eventually reach. This number will eventually reach. 5 will reach, 1 will reach, and then only one max operation will be required. Will I require max operation always? Because, so if w is there, let's try to club these together. If w is 2 to the power n, to the power n, and so on. So it will take the 1, 2, 3, 4. So it will take one. It will take all the max operations up here. It will take any operation. Yeah, sure. So I think it should be the answer. Does it have many summations? To be honest, it has 23 summations. 18, 18, 9, 111. Okay. W is this, n w, right? And then w. Power 2 to the power n. Cool. So 2 to the power n, this is there. Too long. Cool. 2 to the power n. Is equal to val I plus plus answer dot pv I. So what I can do is I can take this element जो मेरे को w बनाना है to be at one of the extreme corners, and then all the max elements together, because this element will only coincide after these, and then it will have to be the max. Cool. 2, 1 answer dot pbi I equal to 0, I less than n, I plus plus I less than see out answer of I What? How is this a permutation? Oh, array you found. Alright, so I don't have to return the last array. I'll have to return the whole tree. Cool. Hmm. Hmm. Okay, so now what I'll have to do is val multiply is equal to 2. So now I have to make answer of size val. Cool. And answer of now val pi is equal to 2. So int j is equal to val minus 1. Cool. Answer of j is equal to I. J plus plus. Answer of j plus plus less than answer. Val has been put. Val minus 2 तक जाएंगे. 0 to val minus 1. Val, j is val less than val. तो कुछ करेंगे. Cool. And so answer of I will be minimum of this, but if any one of this is this, let's suppose max of answer of 2 into I plus 1 comma answer of 2 into I if job is greater than W, answer of I is equal to max of answer of 2 into I plus 1 comma answer of 2 into I, else answer of this is minimum of this, and this is this. I'll just do this. Okay. Hey. One, 1, 3, 1, 2, 3, 4. Haha. Yeah, multiple answers can also be correct, right? But the answer has to be one greater than equal to W. Okay. Nobody is this equal to this. I'll always carry from here to here, right? This is logic is array yaar. Hmm. So they are 36 people have made this. 113123422312 341. लेट्स सी. अरे चार है, पांचवा क्यों नहीं आया? चार ही तो है. ओह, वो थोड़ा. Will it accept? That's the question. Correct answer, bro. Bro, what the fuck, bro? 37 people only have made it. Bro, I think I should leave the contest because rest problems have zero submissions. Or should I make them? Let's try to be the first one to submit. Oh my god, bro. Oh my god. Yes, bro. Come on. Let S be a string of length n containing only characters LR. I suppose I should not give, or I should see if I make these two, I will be global rank 1, right? If I solve both of them, I'll be global rank 1 today. Let's try. Let's try. Matching order. S be a string of length n containing only characters LR with the following properties. N is greater than 3, S of 1 is equal to S of 2 is equal to R, and S of n is equal to L. Cool. Suppose there are strips of n cell containing numbered from 1 to n from left to right. Suppose you are standing at position X on the strip. Then if S of X is equal to R, you will move one step right. If S of X is equal to L, you will move two steps left. Your position will always lie in 1 to n. Cool. So 26 global rank, right? Come on, rank 26. I suppose this will make me exceed 1900. So I will be very much closer to 5-star. Okay, zero submissions, yeah. Should I skip my dinner for this thing? Let's see how this problem is. The strip of n cells numbered from 1 to n from left to right. Suppose you're standing at position X on the strip, then S of X is equal to R, then you'll move one step right. If S of X is equal to L, you will move two steps left. You done with the string, eh? Exactly n times position A of I. Cool. Okay, so if I set on I and then I perform the steps n times, do I reach again here? So I suppose what does this question is, it's a question of BFS only. Cool. So After applying n operations, I want from my position to change from position I to position, uh, let's say a of I, right? So I'm standing at s of I, right? I'm standing at I. Now I'll have a strip. This is R, this is R, and any characters, and this is L. And I'll move my. I'll try to start to move from here, and I'll apply n operations. If it's L, I'll move 2 steps back. If it's R, I'll move 1 step forward, and I'll have to make a grid. I'll have to make a strip such that for all the values in A of I, if I start at an index I, after performing n operations, I end up at A of I. Cool. So cool. And what if there doesn't exist a grid? No, no. Uh, mm, mm. I suppose this is my sign. I should leave. Global rank 26 is not that bad. Okay. I'll have my dinner. Bye bye.